can utilize it for the what are the inputs we required to utilize that one, because I tried in the Minitab, but I can't able to go through on it.
Okay, good that you raised the point. We will start with Pareto. So first of all, this particular session is mainly to clarify on your doubts. So doubts as to, you must voluntarily ask all your doubts so that you can go out very happily at the end of the course. Otherwise, what happens? All the doubts will remain with you and that will pull down your confidence, right? So we have one good question. I am just opening a document, a data file. So let it open. So first of all, Pareto. What is Pareto? It is one of the 7 QC tool. I hope all of you know, right? One of the 7 basic quality control tool. Every company, every professional must be very familiar to use Pareto. It helps us to prioritize our focus. It helps us to prioritize our focus. Let us say there are 100 problems. Let us say there are 100 problems. Which problem you want to solve first? Very important question, isn't it? Let us say there are 100 solutions that exist. Which solution you want to implement? Right? So there are 100 factors. Which factor is, you must attack first? So these are the questions you can get answered graphically by the tool called Pareto plot. It is a prioritization tool. It will help you to focus on the vital few versus the trivial many. It will help you to focus on the vital few versus the trivial many. And as far as the Pareto is concerned, it will have an x-axis. It will also have y-axis. It will look similar to the bar chart. But the main difference is in Pareto, the bars will be arranged in the descending order. In Pareto, the bars will be arranged in the descending order. And y-axis, there will be 2 y-axis. One talking about the frequency of occurrence. And other one on the right side will be talking about the cumulative percentage. So the left side axis will let you know how many times it occurred. The right side of y-axis will let you know what is the contribution of a specific, variable, or it can be, defect, or it can be a factor. So let me show it, with the help of some data so that you will be able to appreciate well. Please, all of you confirm. Can you see my Minitab screen? Welcome, Kumari, madam.
Yeah, thank you, sir. Yeah, it is visible.
Very good. So we are just talking about the Pareto, right? Hope you all have learned it in the defined base. And now there is a Pareto data available with me. See here. Can one of you read out what is written here in the column number 1? Just read out the wordings there.
Defective buttons, loose thread, misaligned fabric, fabric stain,
Misaligned fabric.
hemming defect.
That means these are the defects that are happening in a specific industry. I think all of you can now understand it is a garment industry. Am I right?
Yes.
There is a defective button, there is a loose thread, there is a misaligned fabric, there is a fabric stain, there is a stitching defect. And now you have collected all this data after putting effort for about 15 days or 1 month. 15 days or 1 month, all the rejections happened in your company. You have documented. Every time a rejection has happened, you have created a form and somebody has recorded, and that's how you got this information. All of you, do you understand how this information came? Every time an item is rejected due to defective button, it is documented. So in a month, how many time the defect happened? 217 times. All of you are with me on this?
Yes.
So now the data is available. Now I wanted to visualize. So go to Stat, go to Quality Tools. Can you see Pareto chart here, all of you?
Chart, yes.
Go
Yes,
to Stat, go to Quality Tools, go to Pareto chart. And now this window will come. Now it is asking you, where is the defect data? Defect data is in column number 1. So I just click and select column number 1. Where is the frequency? The frequency of the defect is expressed in column number 2. So I click and select. Click and select. And now I just give OK. Is that all of you here are able to see a Pareto getting generated? You can see a graph, isn't it? Yes. Keep saying yes or no with me. One or two.
Yes, sir. Yes.
Yeah, very good. So you can see the bar charts. You can see the bar charts arranged in the descending order. The first bar represents the problem that occurred in a highest frequency, isn't it? Defective button occurred 217 times. Stitching defect occurred 112 times. Loose thread occurred 67 times. It goes on, keeps on going. Now tell me, which problem you would like to attack first? Or which problem will you be interested in attacking first? Come on.
The stitching?
Who want to attack the stitching?
Yes.
Stitching is first or defective button is first?
The defective buttons frequency is more.
Defective buttons according to the frequency. Now we only have the information about the frequency.
Yes.
According to the frequency, the defective buttons is the major issue right now according to the number of frequency. So probably you will attack the defective button first, and then the stitching defect, and then the loose thread. Everybody is with me on this?
Yes, sir.
Right. And now there is, now you all know what is this bar represents and what is the height of the bar represents. Height of the bar is, you can see 217. This is nothing but this number. The next bar height is 112. What is this 112? What is this 112? Number of times the stitching defects has happened. Right? All of you understand the height of the bar now. And now, totally there are about 490 failures. You can total everything. Approximately 490. Out of the 490, 217 are from the defective buttons. So defective buttons alone is contributing to about 44%. Can you see that, all of you? Defective button alone is contributing to 44%. Can you see that, all of you? Please confirm. Do you understand or not?
Yes, sir. It's coming to 44%.
Yeah. You just have to total the count of defects. Let us say it is 490. 217 divided by 490 will give you this percentage, 44.1. That is 44.1. So this line, blue color line, represents the cumulative percentage. Now tell me, 80% of the cost of poor quality is due to 3 defects. What are those 3 defects? If you attack those 3 defects, 80% of the cost of poor quality, the rejections in your company can be fixed. What are those 3 defects? Come on, all of you can stay unmuted. This is not a training session. This is a kind of interaction. You all have to participate. You try to give an answer. Let us give a wrong answer. But important is you must get it corrected. Now tell me, what are the defects? Defects that contribute to...
Defective button, stitching button.
Yes, one more.
Defect.
Loose thread.
40, 20.
Yeah,
loose thread.
So these 3 account to 80.5%. If you attack the first 3 problems, 80% of the rejections will come down. This is the advantage. Now, Abdul, do you understand how the Pareto is helping you?
So that only this is called 80-20, right, sir?
Yeah, that's why we call it 80-20 rule.
80-20 ratio. Okay.
80% of the problem are caused by 20% of the defects, or 80% of the cost of poor quality is caused by 20% of the defects. 80% of the revenue comes through 20% of the products. Isn't it? 80% of the revenue in a hotel comes from 20% of the items in the menu. Am I correct or not? Most of the time people order idli dosa, isn't it? So 20% of the items contribute to 80% of the sales. So in majority of the situation, this 80-20 rule will work. But don't expect exact 80-20. Look here it is 80.5. It can be 80-20, it can be 70-30, it can be 60-1. This is only a thumb rule. All of you are with me?
But most of the issues are came to 80-20. Na?
Yeah, majority will come to 80-20.
80-20, yes.
Majority. If you have sufficient data, you will see that all the rules are working, perfectly.
Definitely.
If you have less data, then there will be slight imbalance. That is statistics. So statistics, you should not expect perfection. Statistics means you should not expect perfection. It is only prediction. It is only estimation.
Statistics is based on the continuous data, so that only this prediction will be available always, right?
Exactly, correct.
Yes.
So now see here, the 217 split up is given in column number 6 and 7. Can you see that? Out of 217, 146 rejections happened in the shirt section. Likewise, it is going on. So this is nothing but stratification, drilling down, right? So let me plot another Pareto with the split up of the 270. Go to stat, go to quality tools, go to Pareto. Now defects is available in column number 6. I click.
I'm getting voice disturbance.
There is mute. Yeah, I am muted. And then the count information is available in column number 7. Click select. Now I have selected it. I give OK now. Now what happened? One more Pareto has come. All of you, do you understand? This is subdivision of the 217. All of you are able to realize that? The 217 is now subdivided, is now further categorized. Now what do I realize? Rejections are happening more in the shirt section. Can you see that, all of you?
Yes,
Rejections are happening in the shirt section. In that particular industry, shirts are getting manufactured in the 3rd floor. Now the project team, has the complete team has moved to the 3rd floor. So far, they have been, moving everywhere. But now they decided to give their focus only in the 3rd floor. You know why? Because in the 3rd floor itself, there is a lot of rejection. Let me keep my focus there first. All of you understand what I am talking now? Out of the defective buttons, 67% of the defective buttons comes from the shirt section only. Now, all the other defects other than defective buttons are now out of scope. Have you realized that? We have decided not to focus on the rejection due to other defects. The hemming defect, stitching defect, fabric stain, all these things are now out of scope. What is in our scope? Only defective button. That too, only in the shirt section. Do you understand what is now coming in your scope and what is, out of your scope? All of you, are you able to realize here after plotting the Pareto?
yes, sir.
Because if you try to do a project like, boiling the entire ocean, you will never be able to complete your project. It is very important that you draw boundaries. I will attack rejections. I will attack only defective buttons. I will attack defective buttons only in the shirts. I am not going to worry about the chudidar section. I am not going to worry about the kurti section and other section. You know why? Because the rejection is more in the shirt section. Now within the shirt section, out of 146, if I go to the Excel sheet, out of 146, 135 rejections are due to button misalignment. 4 are due to button damages. 7 are due to stitching. How do I get all these detail? Can one of you answer this? How do I get all these things?
You collected the data initial stage.
Oh.
Is it through quality control analysis?
Yeah. Like one of you answered already correctly. Like, you have collected the data, isn't it? You have collected the data since you have decided to have the, document the every rejection, the information is available. Otherwise, it will be difficult. You will be struggling to find out, how exactly, the rejections are happening. So now every single time a rejection is happening, the information is captured, right? And that is the reason why. So I think now the issue is some of our participants are not able to attend. Let me just help them with, what can I do? Settings.
Sir, this session will be available in our videos in the mobile app. Is it available?
I will upload this discussion in my channel, and then you can view through my channel so that I will also get some subscribers, and also you will also get the video. All right,
Okay.
that is the deal.
Okay, nice.
All right, so I'll share that link. Okay, anyway, I will take care later. So now there is another split up available. See, I'm subdividing because the number 146 is so big. So I'm just curious to know how this 156 came. Are there any further detail available, right? And now I am going for one more level of Pareto. Stat, quality tools, Pareto. Now my data is available in column 9. I mean defects. The count is available in column 10. Now I give OK. And now you could see one more Pareto. What do you understand out of the last Pareto now, which I am plotting now? Can you tell me, one of you, what do you understand now, seeing this Pareto?
We are now going to deeper into the effects.
Yeah, tell me, what is your understanding after plotting 3 levels of Pareto? First Pareto told you that most of the rejection is due to defective button. Second Pareto told you that the rejection is happening in the shirt section. Now, what is this third Pareto is telling you?
92% complaint are due to misalignment.
Button misalignment. So now think in this direction, what can be done to prevent button misalignment? Straight away, a major percentage of the rejections will get addressed. Do you understand? You call your team and have a healthy discussion. Why the buttons are getting stitched with the misalignment? Is the button stitching is happening manually or automatically? If it is automatically, why misalignment is happening? If it is manually, why misalignment is happening? And now what can be done? What is the process of stitching the buttons in the shirts? How do actually they stitch the button? Look, ask for each and every step while stitching the button. Definitely one step is prone to the failure. Am I right? One particular step, is actually, failing very frequently. That is the reason why 135 instances you have seen button misalignment within a span of 30 days data collection. All of you are with me?
Yes, sir.
Now the project is well scoped. The project is arresting button misalignment issue in the stitch in the shirt section in the XYZ garment industry. Earlier you said reducing garment defect. Reducing garment defect, the understanding is very broad. But now we are saying we are reducing the rejections due to button misalignment in the shirt section in the XYZ industry. Now the understanding is deeper. How many of you can notice that? All of you, right? Which is better? Addressing the rejection is a better understanding, or addressing the rejection due to button misalignment in the shirt section is better understanding, which is giving you a deeper understanding of the problem which you are going to solve. Come on, I'm asking you a question. As green belts, you have to respond. As black belts, you need to respond.
The deeper.
We are gaining deeper insight about the problem. See, don't never ever try to solve a problem without understanding it. Don't do that mistake. First, you try to understand what is exactly the problem. Where is the problem, right? And which particular process is associated. We will solve it later on. We'll solve it later on. But now that we have understood the problem. Clear? Now, problem statement is very clear. Scope is very clear. Scope in the sense, what is that you will address. Out of scope means what is that you are going to ignore. I am going to ignore defects due to stitching, but I am not going to ignore defects due to button misalignment. The in scope and out scope is very clear. So this is how Pareto is helping you. Pareto is actually a bar chart. In fact, it's a type of bar chart in which the bars are arranged in the descending order. There will be two y-axis. Left y-axis will talk about the frequency of occurrence. The right y-axis will talk about the cumulative percentage. The x-axis will represent different types of defects. We generally call them as attributes. Attribute number 1, attribute number 2, attribute number 3. It can be anything. You can say January, February, March, April, May, and then you can have the sales, whatever is required. So that's it about Pareto. Now,
I need one more thing, sir. How we can input the data into the Minitab with the Excel sheet itself, or we need to type it in the Excel sheet, or we need to download it in the Minitab?
Yeah, in the Excel sheet only. See, in Minitab, when you open it, this is how the screen will be. You can see, some kind of Excel icon. You click that, and now this is called your worksheet. This is called worksheet. And here you can type or you can copy paste. You can copy from Excel and you can paste here. Understand? So now data is available, you can work on it. Done. So now I want to talk to all of you about statistics. So what is statistics? According to our understanding so far, we have used statistics at various stages of our life, right? So tell me, what is statistics? Is it a science? Or is it an art?
So it's an art.
Okay. Of what?
Art of figures. Because we in statistics we deal with presentations.
Collection, organization, presentation of basically data.
Very good. Fantastic definition. We all must clap. But in online, the problem is nobody obeys. When I ask all the students to clap, and nobody will clap. At the maximum, they will digitally clap. That's all. Right. So statistics is the science of collecting, tabulating, visualizing, presenting, and interpreting data so that we get useful information out of it. So that we get useful information and we use the information for effective decision making. All of you understand what is statistics? Every single time you collect data, every single time you tabulate the data, every single time you present it. Present in the sense in the form of graphs, in the form of tables, right? And then every single time you interpret it. Interpret it means you calculate something out of it. You calculate average, you calculate standard deviation, you calculate total, isn't it? There are many things you do. Suppose every month, all the expenses, whatever you are doing, you are writing in a diary. You are actually collecting data, isn't it? Hotel, 5,000 rupees. School fees, 10,000 rupees. And petrol bill, 2,000 rupees. This is, you are now collecting data. And then what is the total expense? Total is a statistics. Total is a statistics. Where you have spent the maximum money. Maximum is another statistics. Minimum, where is the lowest amount spent? That is minimum. The difference between the maximum and minimum is called range. I put everything in the form of a pie chart so that I can understand where am I spending more. So that I understand where am I spending more. Now I realize, I'm spending more with, spending on food, going to hotels and buying the groceries and provision items. And this is where I, spend 80% of my spendings is for the food, maybe, right? So I get some information. So what can I do? In certain cases, the spendings may be more in the entertainments. So you can take effective decision. This is called the statistics. So numbers gives information. Hope everybody agrees with me. Numbers give information. And we use the information for effective decision making. And whatever is happened, you are describing it in the form of certain number. Last month, what was your expense? Now you are showing me an Excel sheet. What last month? What was your expense? You are showing me an Excel sheet. The spends on school fees, spendings on the groceries, spendings on the entertainment, spendings on the medical expense. Now everything is available. Now what you have done? You have actually described how you spent money last week. Am I right? Last month. Last 1 month, whatever you have spent, you have described it beautifully in a Excel sheet. This is now called descriptive statistics. Do you understand what is descriptive statistics? Whatever happened, you have described it clearly in an Excel sheet. You have described it in a tabular column. Now the description is called descriptive statistics. Am I right? Sometimes we describe our girlfriend. We write it for 2 full pages. Isn't it? Same manner. Whatever happened in my company, I'm just writing down. A row after the other. And every row gives certain meaning. So the raw material purchase, so many dollars. And the workers, man hours, so many dollars. Machineries repair, so many dollars. So what is happening in your company, you are describing. And the statistics is now called descriptive statistics. Is that clear to all of you? What is descriptive statistics? Suppose if my expenses are going like this, what could be my next month expense? How many of you are very clear now? What could be your expense in the month of December? Anybody, you have some idea about your expense in the month of December? Or November at least, because till October, you have the description written in your Excel sheet somewhere. Now, how much your family is going to spend in the month of November? Anybody here have an answer? Approximately, you would like to share the number with us? How much you will be spending in November? Maybe 30,000, 40,000, 50,000, 1 lakh, whatever it is. If you have a number, then your statistics is inferential. If you have a number, then the statistics is inferential. How do you tell the number before even actually spending the money? You know it, isn't it? You know it. You know the spending pattern. And so you estimated it. Am I correct or not?
Yes.
Now this is called inferential statistics. So all of you are able to now understand the boundary between descriptive statistics and inferential statistics. Right? If you use the data to understand the present or the past, your statistics is called descriptive statistics. If you use data to predict the future, your statistics is called inferential statistics. Inferential statistics is widely used in business for decision making. My sales is going on in this manner. Next quarter.
Because our expectations are related to expectations, so that
Yes.
we are using that numbers in inferential, right?
Very good. So always, business, they wanted to know
Expectation.
in advance. In advance. So there is a huge demand for inferential statistics. So if you sharpen your skills, then you can be a better predictor and you will be respected for that. And then you will be allowed to grow up in the corporate ladder because you are very good at predicting what is going to happen. And sometimes it is also called forecasting, isn't it? It's also called as forecasting. So how much is going to be the demand? How much is going to be the sales? So all these things, but it all depends on the quality of data. It all depends on the quality of data. If the data quality is poor, your predictions will also be poor. So hope everybody is clear with descriptive statistics, inferential statistics. Now, once again, I'm taking you to Minitab. Again, I am in the Minitab screen. Let me open some data. File, open worksheet. Look in sample data. Let me open something. Camshaft. An engineering component, camshaft, which normally
Powertrain.
It's
Powertrain.
normally power drive. And now length of the camshaft is documented. Can you all see?
Yes.
Length of the camshaft. Because length is an important characteristics for quality. You call it critical to quality. Am I right? CTQ.
Yes, sir.
If the length is wrong, and your camshaft will be rejected. If the length is okay, then you can raise a bill for the camshaft, right? So CTQ stands for critical to quality. And now 100 data is available. What is this data is telling? After taking 100 samples, what is happening in my company? What is happening in my camshaft manufacturing process? I'll go to stat. I'll go to basic stat. Can you see display descriptive statistics, all of you? Go to stat, basic stat, display descriptive statistics. Click that. And now, for which variable you want to calculate descriptive statistics? Length is the variable. What is the statistics you want to calculate? Do you want to find out the maximum length, or you want to find out the minimum length, or what is that you want to find out? For that, you click statistics. Look here, how many statistics are there? What is the first one? Let me unselect everything first. Unselect. Whatever is known to us, we will select and calculate. Because only then, we will be using it. We will be able to use it. All of you, do you know what is mean?
Mean is
Yes,
medium number.
Okay. If
I
you
think
say
it
yes,
is average.
all of you know mean. That's all. Now, standard error of mean. All of you know that? You don't know that, right? If you don't know, let us not use it. Then, standard deviation. All of you, do you know standard deviation?
Yes.
yes,
Yes, sir.
So, click that. Variance. All of you, do you know variance?
Yes, sir.
yes,
Yes,
there is.
sir.
What is the relationship between variance and standard deviation?
Variance is between the lower limit to upper limit.
No. Variance is square of the standard deviation.
Okay.
Square of the standard deviation. Coefficient of variation. This RK will teach all of you tomorrow. Coefficient of variation. He will teach tomorrow. And trimmed mean. That also it's sum of the data. All of you know sum. Sum means total.
Total.
Yes, sir.
Minimum, all of us know. Maximum, all of us know.
Maximum, we know.
Range,
Difference between minimum and maximum.
Between the minimum and
difference
maximum.
between maximum and minimum.
Yeah.
And then a few irrelevant items. I'm not going to talk about it. First quartile. Do you know first quartile?
Yes, sir.
First quartile means a point below which 25% of the data you can see. That is called first quartile. Am I right? A point below which
Yes, sir.
25%. Median. Median is otherwise called as second quartile. A point below which 50% of the data you can see, which means above the point, you will have the remaining 50%. What is third quartile? A
Below the
point
75% of the quartile.
75% below. Very good.
Yeah.
Now interquartile range. Q3 minus Q1. Interquartile range Q3 minus Q1.
Q3 minus Q1.
Mode. What is mode? Most frequently occurred data. Most frequently occurred. Most frequently occurred data, right? So this much is enough for us. All remaining also you need to actually learn one by one. Now the first level I am giving okay. Once again I am giving okay. Can you see everything is calculated for you by Minitab? Everything is now calculated. You don't
Yes,
have to
sir.
do anything. You just have to select whichever is required. Now, whatever way you want to use it, use them. Mean, standard deviation, variance, sum, minimum, quartile 1, median, quartile 3, maximum, range, interquartile range, mode. 601.4 occurred 13 times in your data. The data 601.4 occurred 13 times in your data.
Yes, sir.
I can also do, see it graphically. Stat, basic stat, graphical summary. Length, click, select. Give OK. Length is a continuous data. Length is a continuous data. Is that taught to you in the class? Continuous data. Please confirm. Is that taught to you or not taught?
Yes, sir.
Data types. Then tell me what is continuous data. What is continuous data? I think for Irfan, I have taught you. Measurable, beautiful. Continuous data means measurable. Length is measurable. Length is measurable. Continuous data tend to follow normal distribution, right? So now the continuous data is visualized in the form of a histogram. What is this you are seeing here? This blue color bar chart. This is called histogram. Histogram is one of the 7 basic QC tools. First we spoke about Pareto. Now we are speaking about histogram. The histogram will help us to understand how our data is distributed. These length, 597. These are short pieces. But the 602 and all longer pieces. You know the difference? Shorter pieces and longer pieces. What is required is camshaft with the correct length. Camshaft with correct length probably is the center. In the center, 600 mm is the requirement. 600 mm is the requirement. But some of the camshaft are produced shorter in short length. Some of the camshafts are produced longer. Probably they will have the chance of getting rejected. The shorter ones will get rejected, might get rejected. The longer one also might get rejected, right? But in the center, what is there in the center? This is what we actually want. But actually, when I look at this histogram, it is not actually following normal distribution. It is not in the form of a bell shape. Bell shape means, more or less, it will look like a bell. But there is a reason why it is not following bell. There is a reason why it is not following bell. We can actually make it follow the bell-shaped distribution. If it follows bell, then it will be called normal distribution. But in this case, this is not normal, right? So here also some statistics are available. Mean, standard deviation, variance, many things. Now, what I want is, I want to talk to you, all of you, about little bit about the concept of probability, which is very important. Concept of probability, because most of the time we wanted to predict what will prediction is probability. If the probability is more, your prediction will be high. What is the chance for getting rain tomorrow in Chennai? Will there be a rain tomorrow? 90% chance is there. So probably you will, since the probability is high, it will rain tomorrow. Isn't it? So, but at the same time, you still have a chance to escape. Only 90% I said. 10% chance is there for not raining also. Most of the time that also happens, isn't it? So they predict rain and then they declare holiday for the school. Then there will be a complete sunshine on the day. So probability is a prediction. Now you go to graph, go to probability distribution plot. Go to graph, go to probability distribution plot. And now I want to view probability. I want to view probability. You select view. Now you give OK. Now there are several distribution. You can see. Can you see all of you? So many distribution. I don't want to read everything. Chi-square distribution, discrete distribution, exponential distribution. You can't master everything. But in order to handle your business problem, you must at least master one distribution, which is normal distribution. Is that taught to you in the class? It was taught to you on Saturday by Shivasis, I believe. Am I correct? Normal distribution, bell-shaped distribution. And prior to that, when you were studying, 11th standard in the school, that time also it was taught to you. You might have forgotten. So now you have to recall, right? So normal distribution with a mean value of 0. Mean value of 0. Or let me make it simple for you. Let us say in a class of students, the average mark is 75. The average mark is 75. And with a class of 100 students, I calculate standard deviation to be 5. Do you understand what I am talking now? In a class of 100 students, the average mark is 75. The standard deviation of the mark is 5. Now I want to see the probability. I want to see the probability. Probability last one between 2 points. Point number 1 and point number 2. X value and last one. Now what is the average mark I said? What is the class average? Come on, please.
75.
75. So standard deviation is 5. Now let us subtract one standard deviation from the average. 75 minus one standard deviation, which is 5. What will be the value now? 75 minus 5? 70. Now average plus one standard deviation. 75 plus 5. What will be the score now?
18.
Now, when the class average is 75, when the class standard deviation is 5, what percentage of the students could have scored mark between 70 to 80? Do you have an answer for this question? In a class of 100 students or in a school having 1000 students, the school average is 75. The school standard deviation is 5. What will be the percentage of the students who have scored marks between 70 and 80? Anybody here, are you able to answer this question? What would be the percentage now? Let us ask the Minitab only directly. I give OK. Can you see a number? One of you, can you read out the number? What is the probability?
0.6827.
0.6827. In percentage, 68.27% of the students
27.
have scored mark between 75 and 85. This will work in real time. Please understand, mark my words. This will work in real time. Let us say the average height of people in the age group of 30 to 40 in India. So what is the age group of participants here? Maybe should I say 30 to 50? 30 to 50.
Yes, sir.
People in the age group of 30 to 50 in India, their average height is 5.5 feet. 5.5 feet. The standard deviation based on the data is 0.25 feet. The standard deviation is 0.25 feet. Now tell me, what percentage of the people in India in the age group of 30 to 40 will be having the height between 5.25 feet and 5.75 feet? Tell me what percentage of the people in India, particularly age group 30 to 50, will be between 5.25 and 5.75 feet. Come on, tell me, you need to answer. Silence cannot be the answer. You have to tell something.
Nearly about 70% people.
That's what, 68.27 or nearly 70%. Do you think this prediction will work also? You go and check.
Yeah, sir. Yeah.
Go and check. Take 100 people in the age group of 30 to 50, measure their height, type them in the Excel sheet, find out the average height, find out the standard deviation, and now you cross verify. Go to some other place and verify. Again 70% will come. Go to another city, again 70% will come. This is beauty of statistics. This is called the rule of probability. You can call it as golden rule of probability. All that required is you should have sufficient data. You should have quality data. In your business also you can apply. What is required for prediction? Only two things. Average, another one is standard deviation. That's all. Now let me expand the range. When I expand the range, what will happen to the area? Area will increase. Am I right? Let me expand the range. Go to graph. Go to probability distribution plot. Same thing, view probability. Okay. And now keep the same average. See here, same class average, same class standard deviation. You can also call it anything. Let us say the length of the camshaft. Average length of the camshaft is how much now? 75 mm. Standard deviation 5 mm. Shaded area, X value, probability. And now instead of 70, I am typing 65. Instead of 80, I am typing 85. From the data collected from the camshaft which my company is manufacturing, I know few information. The average is how much? 75. Average is how much? 75. Graph, probability distribution plot, view probability, okay. Average is 75. Standard deviation is too much. Can I reduce here? Standard deviation, can I make it 1 mm? So that it looks acceptable for discussion. 1 mm is the standard deviation. 1 mm, it can be 0.5 also. Whatever you want, you put it. Whatever is actual, you put it. In my company, the average length of the camshaft is 75 mm. Standard deviation according to the data is 0.5. Now, I want to know the probability for the camshaft to lie between 69.9 and 70.1. Anyone here, will you be able to answer this question? What is the standard deviation I said? 0. Come on, speak out. What is the standard deviation?
0.5, okay.
Oh, 0.5, okay. Then I will say 69.5, 70.5.
Sir, 75 is the...
Yes, man. What percentage of the camshaft will have dimension between 69.5 and 70.5?
75 is the average. So above 70 is middle data 75.
Oh, I mentioned 75. Sorry. You're right. Okay, 75. Then I have to change it. That is why, you all have to speak. Otherwise, this kind of blunders will happen. So 74.5, 75.5. Now tell me, what percentage of the camshaft will lie between, dimension 74.5 and 75.5?
75.
What percentage of the camshaft? Let me give, okay. I produce 1000 camshaft. 682 camshaft will have the dimension between 74.5 and 75.5. Tomorrow I am going to produce 10,000. Then 6,827 is going to be between these two. Even before producing, even before manufacturing, I could say this will be the range of dimension in my product. Simply because I have the mean and standard deviation. How many of you understand my language?
Yeah, we understand.
Great. Now let me expand. Go to graph. Go to probability distribution plot. Do probability. Okay. Same mean and standard deviation. Shaded area. I want to know both limits. Instead of 74.5, I say 74. Instead of 75.5, I say 76. Now the percentage of the area between the points is expected to increase. All of you agree with me? Because I expanded. So 68.27 will now increase to 95%, 95.44. 95.45% of the camshaft my company is manufacturing will definitely have dimension between 74 and 76. Suppose customer is okay up to 74 and 76. 95% of my products are safe. Do you understand? If customer has, suppose if the 74 and 76 are the specification limits given by the customer. Customer says 75 plus or minus 1 mm is acceptable. Now what is 74 now? Lower specification limit. All of you are familiar with the term specification limit? Yes or no?
Yes.
Lower spec is 74, upper spec is 76. Your mean is 75, standard deviation is 0.5. Now I am making a beautiful statement. 95% of the camshaft will be accepted by the customer. I have only taken a sample of 100 camshaft, calculated the mean and standard deviation. But next 3 months, I am going to manufacture thousands of camshaft. What will be the rejection rate? 5%.
5%.
How do I know?
95%.
These numbers, you must remember first of all. Now 75 and 74. What is the distance between 74 mm and 75 mm?
1 mm.
1 mm. In terms of standard deviation, how many standard deviation you can see here between the two?
2 standard deviation.
2 standard deviation. When you move away from the center by 2 standard deviation, 95% of the data will fall inside. Do you understand? When you move away from the center by 2 standard deviation, what percentage of the data will fall inside? The data is nothing but your products. So 95.45% of your products will always lie inside 2 sigma limits. The 2 sigma limits are called warning limits. The 2 sigma limits are called warning limits. Suppose when I extend further, stretch further, 95 will further increase. So by going up to 2 sigma, I am able to understand about 95% of my output. When I go further, I can understand better. All of you understand my language? When I stretch further, I can understand better. Let me do that. Go to graph. Go to probability distribution plot. View probability. Okay. Keep it normal. Keep the same mean and standard deviation. Go to shaded area. Instead of 74, now I am saying 73.5. How many standard deviation now I am moving from the center?
3.
3 on the left side. Now similarly 76.5. 3 on the right side. Now the points 3 sigma away from the center. They have a special name. Can anyone spell out the name or pronounce the name? 3 sigma from the center. The point is called control limit. Am I right?
Yeah.
The point is called control limit. Now let us understand what percentage of the data will be inside control limit. You okay? Now tell me what percentage of the data are inside the control limit.
99.73.
99.73%.
You almost know everything about what you are producing. Now, 99.73% of your offerings will definitely stay inside the control limit. Am I correct? Suppose if the customer is okay up to 73.5 on the left side, 76.5 on the right side, what percentage of your products are now acceptable? Tell me. Come on, you need to answer these kind of simple questions to confirm the learning.
100%.
99.73% of your products are now acceptable because I am placing the specification limit exactly on the control limit. Control limit is a point which is at a distance of 3 sigma away from the center. Center is always average. So this is left side is lower control limit, right side is upper control limit. If the specification limit and control limits are overlapping, 99.73% of your products are safe now. 0.27%, right? 0.0027% will be the rejection. Yes, I'm right. 99.73, 0.27. 0.27% is the rejection, 99.73 is acceptable. So what is the secret here? Do you get any learning here? If my standard deviation is, suppose, let us say, customer specification remains same. Let me fix the customer specification. See here. Customer is okay to keep the specification here. Now, I am reducing my sigma. Sigma is how much actually right now?
0.5.
0.5. If I reduce the sigma, you know what will happen? If I reduce the sigma, what will happen? Let us say sigma equal to 0.25. Sigma equal to 0.25. When sigma equal to 0.25, what will be the location of my control limit? One of you tell me. Center is here, 75. In order to locate the control limit, how many sigma I should move out?
0.25.
0.25 multiplied by
3.
how many standard deviation I should move out?
75.
0.75.
Yeah, 0.75.
So come out by 0.75. Now your 75.75 is here. What is this line called? 75.75?
Control limit.
Upper control limit.
Yeah.
Similarly, I want to see my lower control limit. Move to the left by 0.75. Now what will be this point? Value? One of you tell me.
Lower control limit.
Now what is the value?
74.25.
Are you sure?
Yes, sir.
Yes, very good. 74.25. Now this is lower control limit. Now tell me, from lower control limit to upper control limit, what percentage of the products you have manufactured is expected to lie between lower control limit and upper control limit? What percentage?
9.97.
99.73% of your products will certainly lie between 74.25 mm and 75.75 mm. Hope all of you agree with me.
Yes.
But customer is okay up to 73.5, which is lower spec. Also okay up to 76.5, which is upper spec. Now, what percentage of products will be accepted by your customer? Definitely more than 99.73. Definitely more than 99.73.
Yes,
all of you agree?
Yes, sir.
But not 100%. Because always there is a chance, isn't it? This curve goes up to infinity. It goes up to infinity. On the left side, it goes up to minus infinity. We never see where is infinity. So a small percentage for failure is always there. But my success percentage has increased more than 99.73. And now under this condition, one of you please tell me, from the lower spec till the center, how many sigmas are here? Anybody able to find out?
6.
6 sigma. Similarly, on the right side also you have 6 sigma. This process is called actually a 6 sigma process. This is called a 6 sigma process. What is customer can tolerate up to this? Customer has given you this much tolerance on the right side. Am I right?
Yes.
But your process stretched its control limit only to half of it. It is something like you are giving your child a pocket money of 20 rupees. But your child carefully spends only 10 rupees. And the balance is put in a savings account. Now, what is the pocket money you are given? 20 rupees. But how much is spent? Only half of it. Do you think savings is good? Good habit? Definitely it is good, isn't it?
Yes.
Similarly, customer has given you a tolerance. 75 to 76.5, 1.5 mm tolerance, both sides. But how much tolerance your process consumes? Half of it. The balance of will save you when there is a necessity. When something goes wrong, the balance of will come and save you. Logical? Since you are consuming only half of the tolerance, you have made your process doubly capable. You have made your process doubly capable. You are giving your wife every single month 30,000 rupees monthly expense. But your wife is spending only 15,000. Next month, there is a delay in the salary. Will you still be able to run the family very comfortably? What is required for one full month is already available, isn't it? Is there in the form of savings. So this is what can happen even if something goes wrong in our real-time business. The machine can undergo wear and tear. Sometimes an operator might take leave and some other operator will run the machine. Isn't it? The supplier's input quality might change. Even when certain uncontrollable factor play, sometimes a controllable factor itself can go wrong. You still have extra 50% tolerance cushion. That will ensure your project is still your product is still accepted by the customer. This is called Six Sigma process. All of you understand the meaning of a Six Sigma process?
Yes, sir.
Now the minimum success. The success rate is 99.999%. All of you understand? 99.999%. If you produce 1 million pieces, how many pieces? 1 million, which is 10 lakh. How many pieces will get rejected? How many pieces? 6.8 pieces will get rejected. Why 6.8 pieces? Rejection can happen both sides. Length more than 76.5, rejected. Length less than 73.5, rejected. Imagine some other scenario. Let us imagine a company like Swiggy or Zomato. All of you know Swiggy and Zomato?
Yes.
So when you are manufacturing camshaft, the CTQ is length of the camshaft. Suppose if you are a company like Swiggy or Zomato, what is critical to quality now?
Timely delivery.
What is that? Delivery time, right?
Timely delivery.
Yeah. Time to delivery. Yeah. How much time you consume to deliver the item? So now according to the graph I am showing now, the average delivery time in a particular pin code is 75 minutes. Because your networking is very poor. You're networking with the hotels, you're networking with the delivery boys. and the kind of setup you have is very poor. That is what is, appearing in your average. The average delivery time is how much? 75 minutes, which means nobody is going to book, the food through your company because the average is more. Nobody can wait for 75 minutes, isn't it? We all expect the food to come in around 30 minutes. Am I correct now? If it is 30 minutes, we all like to, use the service, but 75 minutes is too high. And now, let us say the same, let us apply the same conditions. Average delivery time is 75. Standard deviation is 0.5. And now, if the food arrives after 76.5 minutes, probably customer might get a bad experience, might get dissatisfied. Am I right? Because you have promised that food will arrive in 75 minutes. But even after 75 minutes, he waits for extra 1.5 minutes. Even then, there is no signal about the food arrival. So customer will definitely get frustrated. Am I right? And now the delivery will become a free delivery. That is what the Zomato and Swiggy are telling, isn't it? If the food is not arrived within 75 minutes or within 30 minutes, the food is free. And now rejection is happening beyond 76.5. All of you understand why rejection is happening here? Yes or no?
Yes.
But on the left side, if the food arrives 10 minutes early, do you think that will also dissatisfy your customer?
Not really.
No. Now this is not a failure at all. If the food arrives 5 minutes early, it is not a failure. So that means the process is one-tailed, not two-tailed. The process is one-tailed. The tolerance is sensitive only on the right side, but not on the left side. So the process is one-tailed. For a one-tailed process, rejection happens only on the right side. Now the number of rejection is limited to 3.4. All of you understand?
Yes.
This is what is called, 3.4 DPMO. Generally, people say, a Six Sigma process assures a success rate of 99.999%. If at all there is a failure, it will be definitely less than 3.4 DPMO. What is DPMO? Defects per million opportunity. All of you understand how the 3.4 comes? 3.4 is the failure rate you can expect from a process operating at a Six Sigma capability, provided the process is one-tailed. Two-tailed means 6.8. One-tailed means 3.4. So all these things we are speaking based on our knowledge on the normal distribution. Based on our knowledge on the normal distribution. Hope my screen is visible to all of you. Am I right?
Yes.
So, yeah. I think Surya Narayanan, you need to check. Right? I could see only your comment only now. So any questions to me? Is this learning helpful? Because we have exceeded 9 o'clock.
It's very useful.
Very useful, right? So based on the data only, you do all the prediction, right? Where is the center? How much is the variation? Variation means spread of the process. If sigma is high, what will happen? The process will spread heavily. When sigma is high, the process will spread heavily. When the process spread heavily, what will happen? Control limit will start moving beyond specification limit. When control limit goes beyond specification limit, the rejection rate will increase. The goal in any business scenario is try to see the control limit well inside the specification limit. Try to see the control limit well inside the specification limit. Why are we very much concerned about control limit? Can anybody answer this question before we close for the day? Why are we concerned about control limit? Because control limit accommodates 99.73% of the area under the curve. Am I right?
Yes.
Control. So you will be able to conclude about 99.73% of the products. And why specifically 3 sigma? Why specifically 3 sigma?
That is how the mathematical formula has been derived since the inception. That's how 3 plus 3 is 6 sigma.
Yes. Let us close it, with the one by talking about one simple example. Imagine you all, have a, big mango tree nearby your house, and you want to hit a mango, right? Because you like mango, so you wanted to get it by throwing stones. Now you have handful of stones. Now you are throwing at the mango. If you are really, good at throwing at the mango, your stone will hit the mango. Am I right? Your stone will hit the mango.
Yes.
Suppose if it is not hitting, it may miss the mango by a small margin. Let us say the margin is 1 inch. If you are hitting the mango by 1 inch, I can still consider you as a professional. You are good at throwing stones, you are good at hitting the mango, but by luck, you missed it, or by luck or bad luck, you missed it by 1 inch. Suppose you miss it by 2 inch, still I can see you as a professional. Let us say you miss it by 3 inch. I can still admit that yes, you are a professional. Suppose if you miss it more than 3 inch, I will lose my confidence on you. Because you are missing by a huge margin. So generally, plus or minus 3 is used for control limit. In my example, I kept 1 inch as the standard deviation. That 1 inch can be 1 feet sometime. 1 inch can be 0.1 inch sometime. It all depends on the kind of data you have. If it is a mango, 1 inch makes sense. I cannot use 1 feet. Hope all of you agree with me. So that all the professionals generally know, they hit that mango. If at all they are missing, they will miss by few inches, not by few feet. If they are missing by few feet, they are not at all professional. Similarly, if you produce products with a huge standard deviation, that is a reflection that you are working in an unprofessional manner. All of you agree?
Yes.
If your standard deviation is less in a way that all the products falls within 3 sigma, then you are doing your best. You are giving your best to do the best in your job. And the process, everything is well in place, well in control. And that's the reason why everything is, all that you produce is coming under the, plus or minus 3 with a lower standard deviation. If you allow the standard deviation to increase, that will cause everything become unprofessional, and there will be a lot of damages, there will be a lot of rejections, there will be, the business results will fall down. The customer dissatisfaction will start happening. Hope all of you understand why we are going by the control limit.
Yes.
All right. So shall we close here?
Okay, sir.
Yeah.
Thank you. Bye-bye. And I'll be meeting all of you on this coming Saturday, because I will also be conducting certain sessions. And again, next Wednesday also, we have similar class.
Sure.
These classes are purely on voluntary basis. Those who are seriously interested in gaining a deeper knowledge, only they can attend. And if you attend the Wednesday classes, Thursday classes, your exam will become much easy job. You will easily you will crack the exam. So make use of all these additional mentorship classes. Thank you. Bye-bye.
Thank you.
Thank you.
Thank you.